Now, Austin, you're looking for problem 15. I can do that. I can do that. Okay. Problem 15 is actually very, very similar to the problem we just did. Okay. So this right here, this is Unit 4, number 15. This is an E2 problem. So we're solving things graphically again. Now, Austin, in your problem you have here, we have two vectors. So these happen to be the same vectors from problem 14. Vector A has a magnitude of 50 meters, points in a direction 20 degrees below the axis. Second vector B has a magnitude of 70 meters and points in a direction 50 degrees above the x-axis. So let's just plot those vectors because we're asked to do some stuff with them. Okay? So if we plot our vectors, draw myself a little axis here. Vector A, as we saw before, was kind of being pulled down this way by 20 degrees. And vector B was kind of existing for us, kind of existing for us a little bit longer and up like this. Okay, so right here what we have is this is vector A, and then right here, this is vector B. That's what we had from the last problem, right? And we said head-tail method, and with the head-tail method, we saw the shift, okay? But this problem is asking us to do something a little different. This problem is asking us not to do A plus B. It's asking us to do A minus B in order to get our resultant vector, which in this case, they're calling D, okay? So it's a little bit different. The key here is this negative b. That's where everybody gets thrown off. What we can recognize is that negative sign there. That negative sign is really, and you know, from your math class, you can think about it this way. What we're really doing is we're saying, what is A plus head-tail method? That's what the plus sign is. Vector negative b. So we want the negative b vector here, okay? So in order to get the negative b vector, we need to ask ourselves this question. How can I get a negative of a vector? Well, let's think about this. The negative of something is often thought as the opposite, okay? So how can you have an opposite of a direction? Well, if I'm going to the right, the opposite of that is to the left. If I'm going up, the opposite of that is down. So the opposite direction, the negative of a vector, is just 180 degrees backwards, okay? So if I look at vector B here, vector B is going up and to the right, so I want to go down and to the left, and I want to go in the exact same line as vector B, but just the opposite direction. So it's going to have the exact same length and just a 180 degree turn on that in order to get vector B. So when I do that, my vector B is going to look something like this. That looks pretty good on my end, okay? Vector B there is pointing in the opposite, so this is technically the vector negative B, okay? And that's what I have there. They're technically the exact same length. If you have a ruler, that's easy to measure, okay, because you know how long you place B. And with the ruler, this is actually really easy too, because you can just lay the ruler along your vector B and then just leave a little bit behind it, and so you can just go backwards. So it's very easy to plot this line. Once you have this, the key here is head-tail method. Right now, your vectors negative B and positive A are tail-tail, so we'll do the shifting again. We can either shift A or shift B. If we go ahead and shift A here, when we shift A, we kind of bring it down, we'll get that. Maybe this one's a little bit short. If we shift B over, we get that. And then, like always, we go from the start to the finish, and this is our resultant vector, which in the problem, they called that vector D. Okay? We would, once again, measure the length, the magnitude, the size, and then starting from the positive x-axis, we'd go all the way around to get the angle. Okay, so we'd have some length, some size, and then we'd have some theta. Oftentimes, it's kind of common that instead of calling that L for a length or a size, we just call that R. It's the position vector itself. It's how long it is. So that's how we're looking at that problem. Okay. Really, the only difference here is because you have this negative b vector right here, that little pesky negative, you're really adding the negative vector. And that negative vector is just the opposite direction as before. From there, same problem as number 14, head-tail method. Get the length, just measuring vector d, and then get the polar angle from the positive x-axis all the way around. Okay? And with that, this problem is over.